I would like to share my PhD research with you, which is about conversational personal knowledge extraction for persona-aware dialogue generation. To start, I would like to begin with a self-introduction. So I'm Yi-Pei from Taiwan and currently supervised by Nakayama Sensei at University of Tokyo. And my research interest lies in NLP area, including the dialogue, which is my main focus in my PhD research. And before, I also done some research in question answering and information extraction. And I'm also currently working with Matsumoto Sensei at Riken. Okay, so now let's go back to our talk today. So in this talk, I'll first introduce the persona, what is the persona-aware dialogue generation, and I'm going to talk about what the task is, like you may not know what is persona, and how to evaluate the dialogue systems and what are the current challenges. And then I'll introduce our proposal of conversational personal knowledge extraction to address some of the challenges. After that, I will introduce how to use the conversational personal knowledge to improve the quality of dialogue generation and to detect the dialogue inconsistency, especially multi-agent dialogue. Okay, so let me start with some basic background of dialogue generation. So depending on whether there is a specific goal for the dialogue system to accomplish, dialogue generation can be categorized into two main types, the task-oriented dialogue and open domain dialogues. Task-oriented dialogues are designed to accomplish some specific tasks within a certain domain. So they are often used in the scenario with a clear goal, such as making a restaurant reservation or booking a flight. And most of these task-oriented dialogue systems rely on a pipeline systems, so containing several modules to keep track of the conversation progress until they finish the goal. On the other hand, the open domain dialogue systems are designed to engage in general conversation without a specific goal. So as shown here, open domain dialogue generation usually rely on a single end-to-end model, which takes the dialogue context as input and directly outputs a natural language response. So these systems aim to provide responses that are coherent, as human-like as possible, while covering a wide range of topics. And it is more challenging than the task-oriented dialogue because there could be many possible responses to a given utterance. The development of open domain dialogue generation has evolved dramatically, beginning with rule-based systems that rely on fixed templates. And then the retrieval-based dialogue systems becomes the mainstream, which selects the responses from a pool of dialogues. Followed by the development of encoder-decoder generative models. They view the dialogue generation as a form of the translation. And after Transformer was introduced, pre-trained language model-based dialogue systems further improve the quality of dialogue generation. However, they are often trained on large quantities of data. So they consider dialogue generation as a static supervised learning problem. So they might introduce some inconsistency. So you can see the example on the right-hand side. For a very similar query, there might be two opposite response, but both are valid. So the dialogue systems that learn from this large data may exhibit inconsistency behavior. And then recently, everyone knows that large language models, they are game changers. And like ChatGPT, they dramatically shift the landscape of the dialogue systems. And they can provide fluent, context-aware, and human-like interactions. In the open domain dialogue generation research, there are some specializations. For example, persona-aware dialogue is one of the most critical specializations. So a persona is defined as the information related to a person, which might include their background, preferences, experience, relations, and so on. So these are some examples of persona sentences. Note that, so we will talk about this later. Not all personas are presented in this form, but most of them are in this form. And a persona-aware dialogue systems are given the personas of the speakers and try to generate the dialogue based on the given persona. And there are other specialties that I'm not going to details today, but the persona-aware dialogue generation is so far still the most challenging dialogue task for the current LLMs. So although you might feel that LLMs are very powerful and can do everything, but in different types of open domain dialogue generation, they are still has some challenges to tackle in the persona-aware dialogue generation. And my ultimate goal of the research is to develop companion dialogue agents, for example, the Baymax or Doraemon for all. And although many other factors are very important to the goal, I think persona-aware or personalization is the most important. So there are two aspects. One is to model the user persona to generate the personalized response. And we also hope that these dialogue agents can have their own personas so that they can adapt to each individual. For example, we can tell, given these dialogues on the left-hand side, we can tell that the blue response is better than the green one based on our understanding to Nobita's persona. Because he's not good at sports, so he's worried about the sports day is coming up. So if you don't know the user's persona, then when seeing an occurrence such as sports day is coming up, then the natural, maybe the more common response will be, oh, that sounds exciting. But if you know Nobita, then you might say that, oh, don't worry, we'll find a way to make sports day fun for you. Yeah, so on the other hand, everyone is unique. So if we want to create a companion dialogue agent that match to each person, each agent might need to have distinct personas. So that's the motivation of the persona-aware dialogue generation. And there are also, it can have several applications, such as we can build more personalized chatbots. We can even be like a form of a continuation of life. If you feed in some people's data and then you want to talk to someone that already passed away. And the persona-aware dialogue generation can also be used in writing scripts of dialogues, such as creating the dynamic game interaction or help with the story generation, novel generation, or movie generation. And currently, the most widely application is the synthesized data sets. So many dialogue data sets, they rely on large language models to generate a large amount of dialogue data to train their chatbots. Okay, so now I'm going to talk about the roadmap of persona-aware dialogue generation. They are mainly evaluated by the fluency, coherence, factfulness, consistency, and diversity. So older works that focus on the fluency, coherence, consistency, and diversity, but more recently, as LLMs becomes more popular, then factfulness also becomes an important factor. And these are some developed challenges of the persona-aware dialogue generation. And in this thesis, we propose the conversational personalize to solve the consistency and diversity issues. And we tackle the challenges of persona selection and unknown persona modeling. Besides, there are many different types of dialogues. So among all these dialogue properties, we focus on the multi-session dialogue, and our last work focused on the multi-agent dialogue. Okay, so here are some challenges and the contributions of this the works that I'll mention today. So first, there are some variations in the problem definitions in personalized dialogue generation or persona-aware dialogue generation, and there is no systematic review. And therefore, in the first section, we'll talk about a survey on the persona-aware dialogue generation, and we identify some challenges and opportunities for future research. And then, in the real world scenario, persona is usually unknown, or personas are limited in the training data. And therefore, we propose the conversational personality extraction task. We construct the data set and we benchmark the approaches for this task. To ensure the persona consistency and while balancing the diversity, we propose a novel generation strategy, and we validate the effectiveness of conversational personality in dialogue generation. And lastly, we propose the dialogue error detection and correction pipeline, leveraging the personal knowledge. And we also validate the effectiveness of our systems. Okay, so now I'm going to talk about the overview of persona-aware dialogue generation. In this section, I'll answer mainly these three questions. What is persona? What are persona-aware dialogue? How are the persona-aware dialogue systems implemented? And how are they evaluated? We provide a comprehensive analysis over 25 works from top conferences between 2021 to 2023. So this is a summary table. First, about the data, I'm going to introduce the benchmark data sets, which is the persona chat, or sometimes you will see conv AI2. These two data sets are essentially the same data sets, but the conv AI2 has the additional test sets. So a typical dialogue example is shown here on the right-hand side. So each person each speaker will be provided with about 5 sentences of persona. And then they'll chat with each other and try to get to know each other. And I think if you look into the personalized dialogue generation literature, then you might often see that this data set is being used. And the persona can be represented in different forms. So the most popular form is the description profile sentence, like the one in this persona chat data sets. So there might be several description sentences like this. It might not only be a simple sentence, but it might be complex sentence which has clause. And it can be a key value pair. So most of these personas are from the web crowd data sets because they can get this kind of metadata from the website. And some works, they use the implicit persona, which means they use the user's history utterances as the and they like encode it into embeddings and use those embeddings as a representation of the user persona. So this is an implicit way to represent the persona. And the source of data sets, there are two main sources. One is from crowdsourcing and one is from social platform. And the source will affect the data set size and the number of utterances. There are many problems tackled in the literatures, and I mainly categorize into these approaches. As mentioned in the beginning, the research can be categorized into two main streams. One focuses on modeling the user persona, and the other on endowing the agent with a persona. And the problems tackled in each line of research is different. But these two lines of work, they might both use the personalized dialogue generation as in their title. So because of time constraint, I'm not going to go into details, but you can look into the papers for more details. For the evaluation, most of these works, they evaluate from these 4 aspects because they are mostly not involved large language models. So they are mainly evaluate on fluency, diversity, personalization, and coherence. And for personalization evaluation, there are 2 most important metrics. One is the persona F1 or persona coverage. This calculate the similarity between the predicted response and the persona. And the C-score, which is the consistent score, is to calculate the consistency between the response and the persona. Okay, so for the here we'll discuss some limitations of the personalized dialogue data sets. The first limitation is the language diversity. So current dialogue data sets are mainly in English and Chinese, and the translated data sets, they lack the rich cultural backgrounds embedded in different languages. So we might need more language variations of the dialogue data sets. And then there is data size and quality trade-off. And lastly, the domain of the current persona-aware dialogue generation datasets are limited to the scenario where 2 strangers attempt to converse. So there lacks a variety of dialogue contexts or situations. And for all the methods, they only focus on most of them, so only one exception. Most of the literatures, they model only one speaker among the dialogue interlocutors. And large language models, they have not been used for modeling the user's unknown persona. but it is directly used to generate a personalized response given the persona, which is not the real world scenario. And also, those works that use LLMs to generate dialogues are mainly evaluated by task success rates. So the tasks are mainly goal-oriented instead of open domain chats. So there's no assessments of the actual dialogue outputs. For the evaluations, all of the works in our survey, they use a similarity-based evaluation, and which has been proved to have low correlation with human judgment. So we advocate to use more latest proposed dialogue evaluation instead of the similarity-based evaluation metrics. Okay, so here is a summary of the persona-aware dialogue generation. So we provide a comprehensive review of recent development in persona-aware dialogue generation, and we identify the challenges and opportunities in data, methodology, and evaluation. Now I'm going to talk about the conversational personal knowledge extraction. So we found that most works in persona-aware dialogue generation rely only on static personas provided by the datasets. And the few works that identify personas from dialogue history either model the whole dialogue history in latent space, or they extract the utterance from dialogue history by a pre-trained classifier. Personas from datasets are limited in number, and they fail to reflect new information from the datasets. On the other hand, modeling persona implicitly refrains users from managing their data, and the whole dialogue history is not equally important. Extracting utterances from the dialogue history will overlook the information from the interaction, such like, do you like sushi? And S2 says, of course. But if you use the utterance level extraction, then the S2 like sushi information will be ignored. Okay. So to overcome these problems, we propose the conversational personal knowledge extraction task. By this task, we can augment the static persona from datasets and model unknown persona by only the most important part of the dialogue. There are also other benefits of representing persona as structured personal knowledge triples. So here we refer the personal knowledge as the structured persona instead of a natural language sentence. So representing persona as personal knowledge has the following benefits. It allows users to manage their own data, and it can combined with other graphs such as social networks or common sense knowledge graphs to further enhance the agent's comprehension. And like slot filling in task-oriented dialogues, it can be used for inspiring future dialogue content. However, there are challenges in data and approach for this task. First of all, there is no such dataset at all. Previous work on personal information extraction, they mainly identify the coarse relations and detect the relation for only one of the speaker, which is due to the data sets they used, which is usually a single person narratives rather than real dialogues. So their data set might be like Twitter's posts. And for approaches, This task is a difficult information extraction problem. To identify the knowledge triple, conventional information extraction approach consists of two steps. The first step is name entity recognition, and the second step is relation classification. However, the subjects of the personal knowledge are usually not the well-known entities such as the speaker one or the little Bob here. And the relation types are highly diverse because we are extracting personal knowledge. So it is much more diverse than conventional information extraction tasks, which might be constrained in like news domain. And lastly, the objects might be very complicated. For example, the object of the first example is little Bob has recovered, which is a cost. Or the object might not exist at all. So to address the lack of data, we construct a data set, personal knowledge in conversation. And we also benchmark 5 approaches on our data sets, including a model we introduce and 3 information extraction approaches and an LLM. So this is an illustration of how the conversational personal knowledge works. So given each utterance, we will extract the personal knowledge and which contains the status, which will change throughout the conversation goes. And these are some, this is the schema of our data. We annotate about 1,000 conversations from daily dialogue data sets. Here are some analysis. So we found that about 30% of the knowledge triples are implicit, which means that the relation is not exist in the dialogue itself, but instead written by the annotators. And we also analyze the subjects of each knowledge triple, and we found that about 40% of the triple subject is the listener. So it shows the importance of dialogue level extraction instead of the utterance level extraction in previous works. And so each color represents the mentions of the entity. So you can see that there is highly overlap of the mentions, which makes the task very difficult. Okay, so these are some comparisons with previous data sets. And we show that our annotations annotate on the actual dialogue, and we have more data, more relations, and supplemental annotations. And we show that our the personal knowledge relations are more distributed than previous knowledge extraction data sets. So here are some, here I'm going to introduce the models in our experiments. Unlike previous methods that identify each item of triple in the given dialogue, we introduce perks. We serializing the triples into a structured task sequence and cast the task as a sequence-to-sequence generation problem. And for prompting the large language model, we introduce a technique to mitigate the out-of-relation problem. And evaluation metrics are precision, recall, and F1 for the subject and predicate, which evaluate the exact token match. And for the object, we use BERT score to evaluate the semantic similarity between the prediction and the ground truth. So the result shows that GPT 3.5 and our fine-tuned model outperforms the conventional IE approaches by a large margin, suggesting that pre-training on general knowledge extraction does not benefit the personal knowledge extraction. And also, GPT 3.5 is better than or comparable with the perks in subject prediction and object prediction. However, we found that the precision of the relation is super low. So we further conduct human evaluation, and the human evaluation is evaluating the whole triple as whether the whole triple is a valid personal knowledge or not, instead of evaluate each item in the triple. And we found that the accuracy of the GPT 3.5 is much, much higher than the perks. So we conclude that the GPT 3.5 is the best performing model for this task. And we also do the analysis to understand why it has so low precision. And so we found that GPT 3.5, they predicts many out of category, out of relations. However, they are also still be correct. Yeah, we did some error analysis to gather the insights for future improvements, but due to time constraint, I'm not going to the details. So in sum, we propose a conversational personal knowledge extraction task to solve the problem of unknown persona. And to fulfill this task, we construct a data set and we benchmark 5 different approaches. Then I'm going to introduce how we use the personal knowledge for dialogue generation. So although the large language models, they can generate fluent response in a single session dialogue, they still face significant challenges in multi-session dialogue generation. So the first challenge is consistency. We found that the longer the history length, the lower the consistency score is. And the second challenge is the diversity. So LLM-generated task is shown to lack variability and richness, which can result in a cycle of diminishing diversity because LLM is also used to synthesize data sets to train the model. And to solve the inconsistency problem, the natural language inference, NLI, is largely used in training process, or the model, so the data or the model are usually used in ensuring the persona consistency. However, in the generation steps, all personas are used, and existing persona selection methods, they use the dialogue context as the query. In this work, we propose a novel generation strategy, response-guided persona retrieval for response refinement. And we also show the effectiveness of extracted conversational personal knowledge. So this is the architectures of the proposed methods and the baselines. So when responding to others, we often formulate an utterance based on the dialogue context. And then we might adjust the response based on our knowledge to the listener. However, conventional generation strategies either directly generate the response given all personas, or they select the personas according to the dialogue context, such as this. They retrieve the persona based on the dialogue context. Therefore, we propose to first generate the general response and then refine it based on the personas relevant to this general response. So to create more human-like personalized response. We also compared using different persona representations, the raw dialogue history, the summary of each dialogue history, and the proposed personal knowledge. The final persona inputs are the unknown personas from the dialogue history and the predefined personas. And for the experiments, we use the dialogues from generative agents, which are LLM-generated dialogues and has so far the longest history sessions as far as we know. And for the model, we use the GPT model as the generator and refiner. And we evaluate the consistency by C-score, the diversity by entropy, and personalization by GPT-4 and persona F1. So here is a final result table. So we can see that our proposed strategy outperforms other strategies in consistency, diversity, and personalization by a large margin. This BOP is methods with refinement based on the BERT model. And I think the results demonstrate the gap between using a pre-trained language model or LLM as a generator. And then the C-score of the goal retrieve is higher than the context retrieve. Indicates that retrieve by the response, which is a goal retrieve, is better than retrieve by the dialogue context. And we also show the personal knowledge is the best persona representation comparing to the summary or the role history. So here are some more comparisons that I'm going to skip. So in summary, we address the key challenges of enhancing consistency and maintaining diversity in multi-session dialogues. And we proposed a response generation strategy and validate the effectiveness of our proposal and the use of personal knowledge in enhancing the consistency, diversity, and personalization. So the last topic is to use the personal knowledge for dialogue inconsistency detection. In this work, we mainly work on multi-agent dialogue. So this is an illustration of multi-agent dialogue, where each agent is based on LLM and has distinct personas. So they take turns to converse with each other. And after one agent, here the blue agent, after this agent chats with multiple agents, this dialogue history will contain the persona of various agents. And we found that the consistency and diversity problem exacerbated significantly in these multi-agent dialogues. So here is an example. So if you look at one individual dialogue, it looks fluent and it looks coherent. However, if you look at the dialogues at different time slots, you'll find that there are actually some contradictions. For example, in the previous dialogue, Jennifer mentioned that she's not really interested in politics. However, in the later dialogue, John says that Jennifer is running for local mayor, so which is not likely to happen. And these are some other inconsistency issues. So for example, Eddie is a music major student studying music theory. However, after he talked with Ayesha, who is working on senior thesis on the usage of language in Shakespeare's plays, he mimic his persona. And after he talked to George, he also mimics Giorgio's persona instead of sticking to his own persona. So this inconsistency is one major problem, and the other problem is the repetition problem. So here shows the ratio of the dialogue which contents collaborate, because we found that agents are often too collaborative. And so we shows that at the later part of the dialogues, almost all dialogues containing the word collaborates. And so in this work, we propose a dialogue error detection and correction pipeline, leveraging the conversational personal knowledge. So this is the whole architecture. I'm going to introduce each component. So one is the personal knowledge for inconsistency detection. Previous works, they used the NLI model to ensure the consistency. However, they are mostly trained with the narrative sentences. So if putting into a dialogue context, they cannot work well. And so we extract the personal knowledge from the dialogue, and then we turn these triples into natural sentence, and we compare the personal knowledge between the candidate utterance and the dialogue database using the NLI model. And lastly, we select the evidence by an LLM. For the repetition detection, we decide a dynamic similarity threshold. And we also design different prompts for the correction module. Okay, so this is the result. So we compare with the baseline without our detection and correction framework, and compare with the original log from the data sets. And we show that we reduce the error rate of consistency, and we enhance the diversity scores by a large margin. And here is the evaluation studies of each modules. So yeah, we found that the performance decreased without any of the module. And we show that without the personal knowledge, if we directly use the NLI model, then it's like we didn't use the inconsistency module at all. So this part shows the effectiveness of personal knowledge. Okay, so here we show that we largely reduce the repetition of the dialogues topics. And this is the human evaluation results. So we show that we have higher quality than the origin by human evaluation or by GPA4 evaluation. Okay, so in conclusion, today I cover these topics: the persona-aware dialogue generation, which includes the we analyze the existing data sets, methods, and evaluations, and we identify the challenges for future research. We introduce the conversational personal knowledge extraction task, construct a data set, and benchmark the approaches. And lastly, we use the conversational personal knowledge for dialogue generation with a proposed generation strategy. And we also use the personal knowledge for dialogue inconsistency detection by proposing a dialogue error detection and correction pipeline using the personal knowledge. So yeah, these are some publications included in this talk and some other publications not included in this talk. So these are all I want to share today. Thank you so much, and I'm happy to take questions.
Thank you very much. It was very impressive presentation and interesting as well. So if any of the participants have any question, please feel free to use the chat, or you can raise your hand using the Zoom feature, and we can also speak as well. So I actually want to know about the future direction of your research. So if you can share a little bit about the future. slides as well.
Yeah, sorry, I skipped it because of the time limitation. So, so there are four main future works that I think can be done. So the first is to develop the approaches for conversational personal knowledge extraction. So as I mentioned in the second section, the GPT is so far still the best performing extraction methods for personal knowledge. However, in the conventional information extraction task, GPT doesn't work as well as the pre-trained models. And one of the reasons is that in most information extraction tasks, the relations are more limited and not so open as the personal knowledge. So how to but using large language model has their own constraints, such as the cost. And so how to develop an approach for conversational personal knowledge extraction is one of the future work. And then in our data sets, we have annotate many supplemental information, but we only use the triple, the subject, predicate, and object triples in our work. But there are other information such as the time or the status of the personal knowledge triple, which are also very important. So how to utilize those informations are also the other future work. And I think with the personal knowledge, there are many things related to knowledge graph that can also be played with. So for example, the personal knowledge inference. If you know that one person is a music major, then we might infer that, oh, that person might know how to play some instruments, for example. So how to do this personal knowledge inference is currently lacked from the personal knowledge extraction work. Right. And then the lastly is about the error detection and correction framework. So in our framework, we only focus on the two, the repetition and inconsistency. So we only focus on these two problems. So we only have the modules to address these problems. But I think there could be other modules that be added into this pipeline to solve other problems in the multi-agent dialogues.
Okay, thank you very much. It was very interesting. So actually, we are almost out of time. So
Thank you.
maybe we can conclude today, and we'll also share your presentation slides with the participants later on. So if anybody has any question, they can also reach out to you.